Hey everyone, welcome. So when you think of the internet, what's the first thing that pops into your head? Wi-Fi signals maybe? The cloud? Something kind of floating around in the air, right? Well, today we're going to dig into the real story. And it's actually way more physical, kind of gritty, and honestly, fascinating. Its reality is buried deep under the ocean. Okay, let's just jump right in with a number that might blow your mind. 99%. That's how much of all our international data, everything, your emails, your Netflix streams, all of it, travels not through satellites, but through this massive hidden network of actual physical fiber optic cables that are just lying on the ocean floor. So yeah, that brings us to the big question. How on earth do we build this invisible giant, this web of underwater wires that literally connects the entire planet? Well, to figure that out, we need to rewind the clock a bit. Our story doesn't actually start with websites or social media. No, it starts with a military problem. The whole core idea of the internet was born from one simple need: to create a communication system that could actually survive a major attack. So back in the 60s, a part of the US Department of Defense called ARPA had this idea. What if we could build a network with no central command, no single point of failure? The key to making that happen was a pretty revolutionary concept called packet switching, and they built it into their network, ARPANET, in 1967. And get this, by 73, this little experiment was already international. And this technology, packet switching, is just brilliant. See, instead of trying to send a huge file all in one go, you chop it up into these tiny little pieces, or packets. Each one of those packets can find its own way through the network, taking whatever the fastest route is. If one path gets blocked, no big deal, the packets just find another way. That right there, that's the secret sauce that makes the whole internet so incredibly resilient. Okay, so having one super resilient network was great, but it wasn't enough. Pretty soon, other networks started popping up, but they all had their own rules, their own hardware. It was like a bunch of separate islands that couldn't talk to each other. So the next huge challenge was creating a universal language that every network could speak. And the solution that emerged was something called TCP/IP. Probably the easiest way to get your head around it is to just think of it like a global digital postal service. It's basically a two-part system that's all about getting any message from anywhere to anywhere else and making sure it gets there in one piece.
Okay, step one, whatever you're sending, an email, a picture, a video, it gets chopped up into those little packets we were just talking about. Just imagine a big stack of numbered postcards.
Then, step two. Every single one of those little postcards gets an address. That's the IP in TCP/IP, the Internet Protocol. It's like the postal worker that stamps each packet with a to and from address so the network knows exactly where it's going.
And finally, step three. Once all those postcards get to their destination, the TCP part takes over. Think of TCP, the Transmission Control Protocol, as the person on the other end who's a little obsessive. They check to make sure every single postcard has arrived, and then they put them all back in the right numerical order to perfectly recreate the original message.
And this whole thing really shows why TCP/IP won out. It wasn't the only game in town. There was another idea, the OSI model, which was, let's just say, super complex, like a 7-layer theoretical wedding cake. TCP/IP, on the other hand, was simple, practical, and it just worked. It became the real-world tool that finally let us build a network of networks, the internet. All right. So that brings us to the next massive shift in the story, how this thing went from a playground for researchers in the military to the public marketplace we all use. And look, the internet we use today didn't just happen by accident. It was actually part of a really clever, deliberate strategy. So here's what the National Science Foundation did, and it was pretty brilliant. On one hand, they told the smaller regional networks, hey, go ahead, take on commercial customers. But at the same time, they said, absolutely no commercial stuff on our main national highway, the NSF-net. And what did that do? It created this huge, gaping hole in the market, a massive business opportunity. Private companies jumped in to build their own networks to meet the demand. By 1995, the NSF just stepped back, cut the funding to its own backbone, and just like that, the private commercial internet was born. And all of this brings us right back to where we started, the physical reality of the internet. Because with this massive commercial explosion, the need for global connectivity went through the roof, and that meant we needed to connect the continents. This kicked off a massive boom in laying those undersea cables we talked about. And I really want to be clear about how totally dominant these cables are. Just look at these numbers. We all think of satellites as being super high-tech, but they handle less than 1% of our data. The other 99%, it's in the cables. And the difference in capacity is just staggering. Terabits versus gigabits. So yeah, that cloud everyone talks about, it's not in the sky, it's literally at the bottom of the ocean.
And what's kind of crazy is how vulnerable this whole system is. You might think the biggest threats are spies or sabotage, right? Nope. It's mostly just fishing boats and ship anchors. They cause the vast majority of breaks. And yes, it's true, though it's super rare, sharks have been known to get a little curious and take a bite.
So, okay, after all that history, from military projects to a commercial free-for-all to thousands of miles of wires on the seabed, where does that leave us today? Let's zoom out and look at the incredible scale of the internet right now.
Well, by 2022, the estimated number of people using the internet was 5.4 billion. That is more than 2/3 of every single person on this planet, all connected to this thing that started as a tiny government experiment just a few decades ago. It's wild.
And as you can see here, this is a truly global thing now. Asia makes up more than half of all internet users, which is just staggering. But this chart also shows us something else, that access is still really uneven across the world. There's still a lot of work to do to get everyone connected.
So, all of this leads us to the future. The internet is just going to get more and more woven into our lives. And that brings up a really big, really important question.
I think this quote from the Internet Society just hits the nail on the head. Basically, the biggest challenge we face isn't about making the tech better, it's about figuring out who's in charge, who gets to make the rules for this global thing we've all built.
And really, that's the question I want to leave you with. As we move forward, who should steer this ship? Should it be governments? Should it be the giant tech companies that own all the pipes? Or should it be us, the global community of users? The answer to that question is going to shape the internet for a long, long time to come.